Greetings to every one of you. So today we are going to discuss another important concept from data structures and algorithm. Sum of subsets problem using backtracking. So this is another application of backtracking. Let me explain what the problem is. For example, there is a given set W contain number of weights 10, 20, 30, 40. Contain 4 weights, 4 values. Now in such a way that you have to select the weights which must be equal to a value that is m. This is a given. For example, in this case, if m is equal to 30, correction 50. If it is 50, in such a way you have to select the weights. The sum of the weights should equal to 50. See, for example, I can select. See, for example, this is the element 1, 2, 3, 4. These are WIs, and I can select the weights. For example, 10, 40. It gives 50. This is one subset. Similarly, the another subset we can get 20, 30. This is also 50. So this xi is nothing but whether the particular weight is included in the sum or not. For example, these are the xi values 1, 2, 3, 4. In the first solution, we got 10 and 40. So that means the first element is included and the fourth element is included. Other elements are not included in this sum. Similarly, the second solution in which we got this value 20 and 30, it is nothing but the second and the third element. Remaining elements are 0. So this xi, it represents whether that particular weight has been included in the sum or not. So here the constraint, the bounding constraints are given here. Summation I is equal to 1 to k, this wi into xi plus w k plus 1, it always should be less than or equal to m. The another bounding constraint is summation of I is equal to 1 to k wi into xi plus summation I is equal to k plus 1 to n wi, it should always greater than m. These are the two constraints which you have to that is follow. So these solutions, what actually we obtained here, these solutions can be obtained with the help of the technique called state space tree. We can generate this tree, and using this tree we can get the solutions. Okay, let us see how to solve this problem using a state space tree. So especially in state space tree, we are going to use the searching procedure called DFS, depth first search method. Let us consider, I am taking the first node, the initial value is 0. So now I am going to that is include the first weight, in which actually this is x, that is a xi in x1 is, this is x1 is equal to 1, and it's another branch, it gives the value that is x1 is equal to 0. So here we are including this x value x1 value. Here we are not including the x1 value. That is the meaning. Okay. If I include, I will get the value that is 10. 0 plus 10. I got the value that is 10. So next value is I have to include the x2 value. x2 is equal to 1. Okay. So what is the value of x2? That is 20. So you have to add this value with this x1 value, and so that my result is 30 now. So now just to move on to the next value, that is x3 value. x3 is equal to 1. What is the value of x3? x3 is 30. So you have to add that value with this. So now the value becomes 60. So 60, which exceeds the value of m, so that what you have to do? We have to that is stop. That is a constraint. So the value, it exceeds the value m. So our m, the value of m is equal to that is 50. Okay, n is equal to that is 4. So it exceeds 50, so that we need not proceed our search hereafter. Okay, so this is not the solution. We can stop here. So now we have to that is backtrack. We have to backtrack. Go here. So what is the value here? That is x3 is equal to 1. Now expand the tree with x3 is equal to 0. That means you are not including the x3 value, so that what will happen, the previous value that will be considered as the resultant value. Okay. Now with this you have to proceed the graph for x4. x4 is equal to 1. So include the value of x4. So 40 is the x4 value. That value should be added with this value, and the result has become that is 70. That is 30 plus 40, 70. So again, which exceeds the specified value, that is 50. So here also this is not the solution, and we need not proceed from here. So what you have to do? Again, you have to that is backtrack and go to this right side of that is x4. x4 is equal to 0. That means don't include the value of x4. So that means you will get towards that the 30 as a result. So here the value of 30, it is totally, that is what is that? It is totally that is lesser than the required value. But again, we don't have any more value to proceed. So here it terminates. Okay. So we don't have any more value. So up to that is x4, we explore. Okay. So no more value to that is continue. So again, it is not equal to our the goal state, that is 50. So terminate the graph. Now what you have to do? You have to that is go back. That is backtracking. You have to do the backtracking. So now proceed with this x2 is equal to 0. Don't include the value of x2. So that means we'll get the value that is 10 as it is. Now proceed the graph for x3. The value of x3 is equal to 1. So what is the value of x3? That is 30. So 30, that is 10. 10 plus 30, you will get 40. Again, it is not the results. Okay. Now proceed with the x4 value. So x4 is equal to 1. Include the value that is x4, that is 40 plus 40, 80. Again, it is not the solution. So now again proceed with that is x4 not included in the list. x4 is equal to 0. So 40, you got the value 40. Again, no more space to proceed. No more value to that is explore. So again, it is terminated. So now again you have to that is go backtrack from here, backtrack. So what is the value? This is x3 is equal to 1. Now proceed with x3 is equal to 0. So what is the x3? You are not including the value of x3. So what the previous value will be? Simply just copied here. So now proceed with x4 value. So what is the x4 value? x4 value is 40. That is x4 is equal to 1. So 10 plus 40, it is 50, which is our goal state. So m is equal to 50. Now we got one result here. So that means x is equal to 1 and x2 is equal to 0, x3 is equal to 0, then x4 is equal to 1. So this is one particular solution. See, for example, if you put this the xi values, this is 1, 2, 3, 4. So what you got the value here, that is x1 is 1. What is here? x2 is 0. What about x3? x3 is also 0. Then what about x4? x4 is 1. So that means this value and this value is present. That means what is that? 1, that is 10 and 40%. You got the goal state, that is 50. M is equal to 50. This is one of the solutions. Now again we can proceed. So this is x4 is equal to 1. Now x4 is equal to 0. So x4 is equal to 0. You got value, that is 10. So again no more search. You cannot proceed to search further here. So it stop here. Again we have to, that is, go back. So this part of this is backtracking. Again you are going here. So here you are going here. This part is over. That is x1 is equal to 1. With that, what is that? The search is over. Now we move on to, what is that? x1 is equal to 0. So from here we have to proceed. So x1 is equal to 0. So from this, now take the value for x2. x2 is equal to 1. So this is 0. x2 value is equal to 1. So include the value, that is x2, that is 20. Okay, include the value, that is x2. Now proceed with that is x3. What is x3 value? That is 30. So 20 plus 30, that is 50. This is also another goal state. Got another goal state, another result. Okay, so here the value of x3 is equal to 1. So what about then this is one solution. Then what about the next solution? Next part is x3 is equal to 0. So this is 20, and from here we can proceed for this x4. x4 is equal to 1 and this is 40. We cannot proceed here. Similarly, x4 is equal to 0, then 20. So again it is not the solution. If you proceed this part, you will get 0 only. Any number you will get a 0. You need not do that at all. So the second solution we got from here, that is x1 is equal to 0. x1 is equal to 0 and x2 is equal to 1. x2 is equal to 1. Then x3 is equal to 1 and x4 we didn't include. So that is x4 is a 0. So we got the solution, two solutions. So one is 1 0 0 1 and another is 0 1 1 0. That means including the value, the set contain first and the last value and the second and the third value. Okay, so that is how actually we got this result. So I explained what is subset problem is and how backtracking can be applied in this problem, how to solve the problem using the state space tree. Thank you very much.